Okay, so please put on your mic as well. So I'm going to try to open our last class. That's Friday. Let's see, this is the last class. Okay, yeah, it's this one. So I'm going to share my screen with you. So remember this from last time? So let's try to refresh our memory with all this. When you find the inverse of an inverse, what you get is, can you see my screen? Okay, when you find the inverse of an inverse, what you get is the function. When the function composed with the inverse in any order, you get an identity function. Okay, if a function and its inverse are the same, it is called a self-inverse function. So these were the major things that we mentioned last time. Okay, so we're going to need that and maybe some other stuff in today's lesson. Today's lesson will be basically about practice. So could you guys try to look at, has anyone attempted anything in question 1? Any of the problems in 1? Can I get some answers? Yes or no will be fine.
I did a few.
Say that again.
I did a few.
Of one, okay. Any other, is there anyone who hasn't attempted any of them?
I did one, like the questions.
Okay, so I just want to know if anybody attempted question 1 and if anyone did not yet, so we can maybe practice some of them so everybody can learn from it. Can I get a response from those that have not attempted it? Because if you have done it already, so we're not going to waste time on it. That's the point I'm trying to make. Clarissa?
I haven't done any.
Okay, Leo? Leo said what?
I haven't done any of them.
Okay, Leo has not. How about Clarissa? No. Your mic isn't working, you know that, right? One of your devices is meant to be your mic. Okay, good. Now I think it's working, so you can speak now.
I didn't finish one yet.
No, I'm not asking you to finish one. Like, did you at least make an attempt, all right? You don't have to like do everything in one. Callista, what's going on? I have to turn my neck to be able to see you. What up? All right, so can someone explain to us one, let's see, I'm gonna share that. Maybe 1A, the question says, which of the following functions have inverses? Where the inverse exists, write down the inverse function. Can someone explain to us how to do 1A? Who wants to? A volunteer for 1A. Maybe I'll leave that on the board, on the screen. For those that have attempted, especially, 1A, please.
For 1A, you take the y value and you turn it into the x value.
Say that again.
For 1A, you take the y values and you turn it to the x value, and you take the x value and you turn it into the y value.
Okay.
So around.
So, yes, you have a point there. So you just switch the coordinates. And how do you know whether it has an inverse or not?
If the x value, if each y coordinate has a unique x coordinate, then it is an inverse function.
So basically, before you could find the inverse, what are you supposed to check for? Because remember, the questions say which of the following have inverses. So you have to be able to justify if the inverse exists or not before you can proceed. Okay? Vena, can you? Nice one, actually, Ethan. That's what we're looking for. Vena, could you take it from there? If can you take it from there and explain if question 1 has an inverse and why, before telling us what the inverse is? Can you hear me? If you haven't attempted it, please feel free to say so.
Wi-Fi is a bit slow. Wait, let me try and change the Wi-Fi.
Does it have an inverse? Does it have an inverse?
I haven't done it yet.
You haven't done it yet. Okay. Who has done question 1 apart from Ethan, please? Question 1A. Krista C, Krista K, Lillian, Nakita. Have you done question 1A?
Yeah.
Okay.
Yeah.
All right. So how about 1B? Maybe you guys can share the questions. How about 1B? Which of you has done 1B? I'm talking to Lillian and Nakita now. Have you done 1B?
No, I just skimmed through the questions.
Okay. Nakita, have you done 1B?
Yeah.
Okay. So how about Lillian explain 1A and Nakita explains 1B? Just add more to what Ethan has said. So explain to the class 1A, Lillian. Then Nakita will explain 1B.
1A has an inverse because for every y value, there's a unique x value. I mean, or is it the other way around? Wait, let me check. So I wrote because there cannot be more than one x that has the same y, and then the inverse is just like swapping the coordinates. So 2, 1, and then 4, 2, and then 5, 3.
Okay, so my point is this. How do you, before getting the inverse, how do you know the inverse exists? That's my question. Lillian.
I mean, if it's a one-to-one function, then an inverse will exist, right?
So the point, we have not even mentioned one-to-one function.
Okay.
At this time. Of course, you are right. One-to-one function is something, for the record class, one-to-one function is something we're going to mention later, okay? It might be next lesson, it depends. We have some types of functions like that. Yes, say that again.
So, like when each x value has a unique y value, that's one. Then they have to.
And the other way around.
Yeah.
Okay, and the other way around. That's the best way to look at it. So if you look at this, 1 has a unique 2, and if you go the other way around, 2 is unique coming back, right? 4 is unique coming back. 5 is unique coming back. This is not like 5 to 3, then something also 5 to 4. Do you understand? So the x coordinate is unique, the y coordinate is unique. It's safe to say that it has an inverse. That's what you meant by one-to-one. Okay? Nakita, does 2 have an inverse?
1B doesn't have a function because like they have like the same y value.
So 1B is not even a function. That's what she's claiming. Do we all agree? Lillian, do you agree with that?
Yes. Yes.
So what is, if how do you know something is not a function? Karen, do you remember? She looks shocked, like, He's like, oh no, I'm not one of those two you're talking to. Why do you call my name? Yes, I call your name. So can you remind us from previous lessons when a function, when a relation is not a function? Do we remember this from previous lessons? When a relation is not a function, you can check through your notes, which is what Brandon is doing right now. I got him. Yes, Mr. Chang, you were going to say something.
If an x value has more than one y coordinate.
So how can you think of this? Think of it as square root of x. Okay, that's the easiest way to remember. Think of it as square root of x. When the inputs of x is, say, 9, you get two different values, 3 and minus 3, right? That's not a function. Okay, that's not a function. So this is what I'm trying to say. Okay. We mentioned something before. So if you want to remember, because sometimes it's understandable when you mix them up. Is it when there's a unique x value or when there's a unique y value? How many of you sometimes mix it up? Signify. If you mix it up, sometimes you mix it up, you don't know if it is unique x value or unique y value. Signify. Aha. So I'm not the only one. So let's suppose I'm in high school, then I'm not the only one, all right? So this is how you can remember. Just know that the square root of x is not a function, okay? Unless you put plus. That was the restriction we did when we justified as a function, okay? Unless you put a plus, it's not a function. Because if you do not put plus, square root of 9, for every entry 9, for example, you could get 3 or minus 3. So having this and this means it's not a function. Okay? So it means there is a y, there are y value, there are two different y values for a particular x, which is contrary to what we mentioned in that class. So I'm going to try to find the board for that class. Does anybody remember the date that we did it? Someone give me the date because I have so many functions and relation. I think I found one. Well, so let's see this. Someone sent a message. Let's see what your message is. All right, Mr. Cheng, that's your message. So let's look at this. Remember this? That was done on February 24th. Wow, by tomorrow it will be exactly 1 month. Happy anniversary, people. So you remember this day? Aha. So I'm gonna minimize my video. Mr. Cheng, I saw your message and you're still there. What up? Or did you send that a long time ago?
I already got the thing I need to get.
Oh, okay, okay. So if you look at this, we mentioned what is not a function. This was actually one of our examples, one of our activities then. So let's see. We said this is not a function, number 4 here especially, it's not a function. Okay, unless you can restrict the domain. Okay, unless you can restrict it. With a restriction, whether the domain or the range, then we can have a function. So here, where is it? Here, okay. A relation is a function if no two y coordinates have the same x coordinate. Okay, or if no two distinct, which means different, ordered pair have the same x coordinate, or if every x value has a unique y value. So you can look at this. The blue one is actually easier, and that's exactly what I'm trying to say here. So let's come to what I wrote. These are two ordered pair with the same x coordinate. And that is contrary to this definition in blue. Sure. That's contrary to this definition in blue. No two distinct ordered pair must have the same x coordinate. Okay? Which means if you are thinking of the inverse, you must be thinking of it how? Anyone? Can you guess? If you are thinking of the inverse now, what would this definition look like? The definition in blue.
No two distinct ordered pair have the same y coordinate.
Exactly. Because by the time it is inverted, the x coordinate becomes the y coordinate. Do you agree, Leo, Brandy? By the time it is inverted, the x coordinate becomes the y coordinate. So all you have to do without working on it is to inspect. Are there two ordered pairs with the same y coordinates? If the answer is yes, it means the inverse of whatever you are looking at is not a function. So we can't have an inverse function. Do you understand that? So let's go to the questions now. Okay, so here are the questions. Look at questions A, B, C. What I said, I'm going to write it as a note for you on the board. Look at question A. Does question A meet the criteria of both? Because it already says the following, which are the following functions have inverse, which I will assume that all these are already checked to be inverse, to be functions. And we can check it ourselves. Do we have any ordered pair, any two ordered pair with the same x coordinates? Do we have it in question 1? Everybody turn on your mic and say something. Do we have it in question 1?
No.
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 Now let's check the y coordinates. Do we have the same ordered pair with the same y coordinates? Two ordered pair with the same y? No. So the inverse exists here. What about question 2? Is it a function?
Yes.
Yeah.
Yes. What about the inverse? Does the inverse give a function?
No.
No. So you can see this is an ordered pair, this is an ordered pair, and they have the same y coordinates. So which means when the so-called inverse is obtained, it's just a relation. It's not a function because it's going to go contrary to that definition in blue. And the definition says no two ordered pair must have the same x coordinates. And that you can easily link to this test. Remember the vertical line test that we did? That's how the square root function fails. Because the moment you bring your vertical line, it fails. This is x equals something. The line is x equals something. So x is the same on this line. But you have, different y values. And you're not supposed to have different y values. Just like here, you have one x value. This is x value, just like maybe this is x is equal to 9. Then this is plus 3, this is minus 3, which is wrong. Okay, so that's why we keep saying you cannot have this two ordered pair such that you have the same x value. And these are different. This is wrong. So if you turn it the other way around, if after the inverses, so you had x1, y1, for example, x2, y2, and it meets the criteria of being a function. But after it is inverted, you're supposed to have your y1 x1, and you're supposed to have y2 x2 after it's inverted. But you notice that actually the two y's are the same, then it means after you find the inverse, it fails to be a function. But you don't have to find the inverse to see the failure. Okay? It fails to be a function in the sense that it's like this, ordered pair with the same x coordinate. So if you come here, oh, these are ordered pair, but they have the same coordinate. They have the same x coordinate, which is, maybe I call it y naught. I want Coke. I want Coke. How can you be drinking Coke when I'm in class? I want Coke. Sorry guys, she's drinking Coke, thereby tempting my throat. That's not nice, right? Someone needs to call 911 on Mrs. A. Anyway, so by the time, thank you. Close your eyes, everybody. I'm just trying to have a little fun here. Let me see the disappointment in Karen's face. She's like, oh no, he did just do that to me. Karen, cheers. Mr. B, you're the Coke man, mixing Coke with malt. Oh, come on. That's not Coke, that's coffee. All right. As I was saying before, I was nicely interrupted because that is Coke. That's nicely interrupted. Okay. So let's say the y values are y naught, okay? These are y naught. It means if you flip them, this is what you have. It means when it is flipped, it fails the blue definition, which means it fails the vertical line test. Then that inverse does not exist because it's not a function, that's what we mean, all right? So by looking at it, you can always deduce if it has inverse or not by checking that blue definition in terms of y this time around. So B is not. What about C? Everybody, what about C? What do you think? Is C invertible? Does it have an inverse? Karen, what do you think? Does it have an inverse? Hey, Miss K, does C have an inverse?
Wait, no.
Why do you say that? Even if you say yes, I'll ask you why do you say that?
Because the x and y coordinates are the same.
Well, there's no crime in having x and y as the same. That's not what the blue definition says.
Oh, okay.
It says for any two pairs, you must not have the same x coordinate. And that is what the vertical line test is all about. Look at this diagram again, the diagram of the vertical line test. Here. Can you see this? Is my video blocking the screen?
No.
Okay, all right, good. Okay, so look at the vertical line test. Can you see that? It means for a particular x is equal to 9, there are two values, which means you have something like this, the green, the one I've written in green. This is what you need to watch out for. As a matter of fact, what you're looking at is what? Everybody look at that question C. What shape is that on the graph?
Straight line.
A straight line. Thank you, Leo. It's a straight line. Okay? And that straight line is, there's something unique about that straight line. Can anybody tell us? You have minus 1, minus 1, 0, 0, what?
Identity function.
Yes, it's an identity function. I was even talking about it in terms of graph now, but you're right. That's a straight line that passes through and meet at 45 degrees. It bisects the quadrants. Do you agree? So when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. Like that. That's a function. That's a function, okay? And I think the inverse is also the same, because this is the line of reflection. Do you remember when you have a function? If this was a function, the inverse should have come this way, right? Do you agree? Do you remember this? The inverse of a function and the function are mirror images about the line x is equal to y, or y is equal to x. So the line y equals x is a function of itself because that's a mirror. Where does the mirror mirrors itself to? It's still the same position, isn't it? So it has an inverse. Karen, does that make sense to you, what I'm trying to explain?
Yes.
All right. So you need to just check for two coordinates of x, and that's for the function. And for the inverse, you check for the two coordinates in terms for the y coordinates. You check for the y coordinates in terms of the inverse. Okay. So how about we give Karen another question to be sure? Karen, can you look at question D and explain to us whether it's a function first and whether it has inverse next?
It is a function.
It is a function. Why is that?
Because for every x, there isn't the same y coordinate.
For every x, there isn't the same y coordinate? Or you mean for every pair, there is no two x coordinates that are the same? I don't know if you're getting my point here. You check 2. Look at this. This is 2, 1. This is minus 1, 0. The x coordinates are not the same. If you check these two also, the x coordinates are not the same. You check this, so for any two ordered pair, the x coordinates are not the same. That's what you should say. That's the easiest way to go about it. Does that make sense? So does it have inverse? Does it have inverse now?
Yes.
Why?
Sorry, what?
I said just try.
Oh, for every y, no wait, for every x.
For every
pair.
Yes, for every pair, yes.
There is no same y coordinate.
That's it. That's it. Last but not the least, let's see. Random question. Did anyone see any? Okay. I'm going to call on Callista now. Callista? Wait, is that your dog?
Cat.
Oh, cat. That's okay. So Callista, could you look at E and tell us if it is a function to start with and tell us why? And does it have inverse and tell us why?
It is a function
E.
because like E.
Mm-hmm.
Yeah. It is a function because like every x doesn't have like every x has a unique y.
Okay, I'm gonna write that blue definition on the board. So it is a function, because I think this is actually easier, because for every distinct ordered pair, okay, for every two distinct ordered pair, x coordinates are not the same. This is the line I think might be easier and not the same. So check any two ordered pair When we say check any two, it doesn't mean you check the first and the second and you forget about the rest. Okay, when we say for any two, we're actually talking about in general, which means every possible two has to be considered. Okay, the x values are not the same, and the inverse will be the other way around. Does it make sense? So Calista, go ahead and tell us about E. I'll leave this on the board.
Can you repeat the question? I lagged just now, so I couldn't hear.
So the question E. So is it a function, and why? Does it have an inverse, and why?
Wait, so
Just look at the definition on the board, and that will help you to tell us if it is a function or not.
it doesn't have an inverse.
It doesn't have a name, but is it a function? You have not even mentioned that.
It's a function.
It's a function.
It's a function.
Okay, because for every two distinct ordered pair, the x coordinates are not the same. Yeah? That's how you explain that. Okay, so you said the inverse does not exist. Why is that?
Because the inverse, one x cannot have more than one y value.
Use the same definition to explain, basically. So it is not invertible, or it doesn't have an inverse because, look at the definition on the board.
Because for every distinct ordered pair, the x coordinates are not the same.
No, not the x coordinate this time.
The y coordinate.
The y coordinates are the same. You can always find two ordered pair where the y coordinates are the same. And I think that's something unique about this. In fact, for all of them, the y coordinates are the same. And you see how weird that is? For every one of them. It means if you find the inverse, okay, if you find the inverse, for just one x coordinate, you have different y values. That's weird, isn't it? That's like a spiral. Looks like this. It's like having something like this. So it's like having something like this. Maybe not. Is it 4 yet? Look at that. That's not a function. This failed the vertical line test because for just one value 2, there are 4 different values, isn't it? 4 different values. Okay, where is it? I'm in the inverse now. This is the graph of the inverse. I'm trying to plot the graph of the inverse. So for that, you're gonna have -2, 0. This is -2, 0, 2, and 4. So this is the graph of the inverse. So the inverse is not a function. Okay, the inverse is not a function. So please take note of that. So the function is probably like this. I don't know, maybe. For the inverse to be like that. I'm just looking at it in terms of translation. Anyway, does it make sense? So that's how we explain that. So quickly, question 2, show that this F inverse, so that F is self-inverse by referring to the graph and using algebra. Let's refer to the graph together. Everybody come with me to the Desmos app. And if you want to plot it yourself, please feel free to do so as well. But you can just look at my screen if you wish. So, Desmos, not DED. Okay. So the function is a rational function, 5x minus 1. No. Okay, 5x minus 1, and denominator is x minus 5. Uh-oh. So how can we look at this graph and deduce that it is a self-inverse function? The first question will be, what is a self-inverse function? Crystal K, what is a self-inverse function?
It's still the same after, like the equation of inverse function is still the same as the original one.
I didn't get that.
The inverse function is still the same of the original function.
Yes, the inverse and the original function are the same. Okay, very good. So everybody remember what the self-inverse function is. Now, how can we look at this graph and be able to deduce that the function that I've just plotted is a self-inverse function? Looking at the graph, how is that possible? Yes. What do you guys think about this question? Can someone try? How do you explain it? Lillian, not yet. If you have something to say, not now.
You can tell that it's a self-inverse function because it is mirrored across the identity function.
Okay, so let's plot the identity function. Maybe that will help you explain better. So that's the identity function. So explain now with this.
So when we say that something is the inverse of a function, we're basically saying that it's the original function, but mirrored across the x equals y line. And if
Okay, I'm listening.
And if it's mirrored across, if the function like in the first place is already mirrored across the x equals y line, then it is said to be a.
Okay, so two things here. I think you have the answer. You are not putting your answer together. Okay. Now you said if it can be mirrored across y equals x, across the identity function. There is no function that cannot be mirrored. As long as it's on the graph, it can be mirrored. So maybe you want to think about what you're saying, because the criteria you're giving us now is, is that if it's a self-inverse because it can be mirrored. Any function can be mirrored. So you're not really explaining why it is a self-inverse function. Leo, you want to try? But I think you have the answer. You're not just putting it together properly. Leo, you want to try?
I don't know.
Okay, do you remember what self-inverse function is, Leo?
The left side is the right. Like, I don't know how to explain.
Okay, so how do I know that a function is self-inverse? Let's start from there. Krista just explained now.
Like, the function is its own inverse.
It's its own inverse, yes. The function and the inverse are the same. Okay, that's a self-inverse function. Do you remember the relationship between a function, the inverse, and this green line? We did that in one of the investigations that I asked you to do on Edmodo recently.
I forgot.
Okay, all right. So we discovered then that if you have a function, let's pick a function. Let's pick a function so we can remind Leo what we're talking about. So I'm going to take this off. Let's pick y equals 3 plus x. Okay, how about we take something 2x minus 1. The inverse of this function will be what? X plus 1 divided by 2, is it? Is it x plus 1 divided by 2, guys?
Plus 1.
L plus 1, yes. Am I right? That would be the inverse. Because this minus 1 goes to the other side, and we have to divide by 2, right?
Yeah.
Okay, so now let's see. This is a function, this is the inverse. Let's see what happens if you put this. Now that is the line y equals x, Leo. So you notice that this line is a mirror image to this. The purple line is a reflection of the black line. The black line is a reflection of the purple line. And this is the line, the reflection line. That's the mirror line. We did that in one of the investigations, I don't know, 1 or 2 weeks ago. Okay, do you remember that now? So,
Yes.
if it is a self-inverse function, can you use this definition to be able to, because Mr. Chang is saying the same thing. The problem with Eden's explanation is not putting it right. Can you try, why is this self-inverse function?
Because it's x equals to its y.
What do you mean by that?
So the negative 20, for example, there's negative, I think is 1, negative 10. Wait.
If you need more numbers, so I'm zooming in.
Okay. It's enough, I think. So negative 2.5, negative 2.5 equals to 2.5. Like if x equals 2.5, the y is 2.5.
Not really. Not really. Karen?
Yes.
Can you try? Why is this a self-inverse function based on all these self-inverse inverse property on the graph that we have mentioned? Can you try? Brandy, I'm coming to you next. Any luck, Karen? I can't even see you anyways. Is Karen still there? I guess not. Brandy.
Is it because when you plot the x and y value, and then
What?
the inverse of it, it's just like they just swap places. I don't know how you say it.
They are looking at it maybe by writing down the coordinates, but you don't have to write down the coordinates. Yeah, you don't have to write down the coordinate. Krista C, what do you think? Crystal? Is this internet problem or what?
Can you hear me?
Yeah, I can hear you now.
Oh, okay.
Crystal, are you saying something? Because I can't hear you.
I think it will be inverse function.
I can't hear you, Crystal. What's wrong with our internet today? Clarissa, can you hear me?
Yes.
Okay. So Clarissa, Lillian, can you hear me? Okay. Yeah. So I guess Karen and the rest needs to check their whatever very well. Okay, Nakita, can you try looking at this graph? Why is it a self-inverse function?
Is it because the graph is symmetric about the line of y equals to x?
That's what I was looking for. The graph is symmetric about that line. What does that mean? The mirror is the same. If you reflect it on this side, on this, can everybody see my cursor? Can you see my cursor, please? All right. If you reflect this, you get that, right? It's actually symmetric. It's the same. Look at it. It's the same. Unlike this, you can differentiate between them. Can differentiate between them. But here, remember, I plotted two, right? I plotted two different functions to have this symmetry. In this case, the symmetry occurs with only the function. So if you look at it, it's symmetric about it. That symmetry is missing if I plot only this one. Look at this. If I plot only this one, there's nothing like a symmetry here. If I plot only this one, there's nothing like a symmetry here. Okay? So if, now look at it. On one side, you have your function. There's nothing on the other side. And if you take the inverse only, you see, you only have it on one side of the line, right? But if you look at this, you have it on both sides, and they are symmetric. So if you find the inverse, it's going to, because the inverse is meant to be mirrored across this, right? Do you agree? The inverse is meant to be mirrored along this line. So whatever that is mirrored along this line is meant to come here, and the line is already there. Can you see that? Whatever that is meant to be mirrored, if you mirror this line, it's meant to come on this side, isn't it? Which is also already there. Let me try to plot this in a different color. Let's change the color of this to some dotted black. No, not you. It's you. Or this, but dotted. Can you see this? Can you see this, guys? Because if you find the inverse is the same function, the only thing that could happen is instead of 5x minus 1, you could have 1 minus 5x. And this, in that case, will be 5 minus x. So this is another way the inverse could look like. Can you see? So for the first one, if you find the mirror of this, it's supposed to be here, isn't it? It's supposed to come here. Look at it. Something is already there. So can you see that now? So this is how you know that it's a self-inverse function. One of the self-inverse functions that we did last time is 7 minus x. 7 minus x. Let's see. Can you see this? Can somebody explain why this is a self-inverse function looking at the graph? Brandy.
Because it is symmetrical at the
About that
y
line.
equals x line.
That's it. It is symmetrical. So the line is in the middle. So such graph is always found on both sides at any time. Unlike this is not found on both sides at any time. Look at it. That's not found on both sides. From this point forward is found below the line. Do you agree? From this point backwards is found above the line. Can you see that? Okay, so this is not self-inverse. I need a response from everybody, please, so I can be sure that everybody gets what I'm trying to explain.
Yeah.
Okay, good.
Yeah.
So that's not self-inverse. That's what Nakita is trying to say. But if you look at this function, at any point on the line, you can find it on both sides and they are symmetric. So if you are trying to mirror this, it's already given. Even though the mirror is meant to be separated from the graph, but the mirror is exactly the same as the graph. That's what you meant by symmetric. And that's how you explain it. Okay? So if someone had asked you to justify if it is, oh, looking at the graph, you could see that the line is symmetric about y equals x. That's how you explain it. You can take note of that. It is symmetric, like she said, about the graph. And using algebra, you will get the same thing. So using algebra, let's put that on the board. Unfortunately, our class is almost over. But the difficult ones are the ones I need to explain. Of course, maybe when we come on Wednesday, we might do more practice. But these are fundamental ideas that I think we need to really understand. Otherwise, something might be wrong. Something might go wrong. I didn't even put today's date. I put it later. Okay. So the function is 5x minus 1 over x minus 5 or 5 minus x minus 5. Of course, it's not defined when x is 5. We know that. By inspecting the graph, the question says, show that f is self-inverse by referring to the graph. So, the first part, by referring to the graph, or from the graph is okay. From the graph, f is symmetric about y equals x. Okay? Or from the graph, the image when f of x is reflected about y equals x is same as f of x. That's exactly what we mean. Because function and the inverse on the graph is such that one is a mirror image of the other. In this case, we'll discover that the image and the object are exactly the same. So the object cut across the line, then we realize the image of 50% of it is exactly the object itself. Okay, 50% of the object is exactly the image. So that's what we mean by it is symmetric about y equals x. So the second question is to use algebra. So using algebra is exactly what we have been doing. So using algebra, so we explain that by finding the inverse. Okay. So using algebra, you say let's y be f of x. If f of x is y, Clarissa, from what does this imply?
Y equals 5x minus 1 over x minus 5?
No, that's not the one. Okay, wait. Let's say let y be f of x. Then this is y equals 5x minus 1 over x minus. Am I writing this way? But this also means something, Clarissa. By definition of function, what does this mean? Or should I say such that? From our function definition, that means something. Crystal K. From here, what can you say? How can you relate them?
Can you repeat the question?
So if y is a function of x, can you give me another relationship? This is in general now. This has nothing to do with this. In general, if y is a function of x, what can you say about x or or y in another form?
X equals inverse of n.
This is what I'm looking for. Okay, this is the definition. So such that y, I don't want it to be behind the stuff. Okay, okay. Such that f inverse of x, f inverse of y equals x. Hope everybody understands this. Talk to me, guys.
Yeah.
Yes.
Okay. So it's very important. It's just like saying sine theta equals 0.5. Then we say theta is arc sine of 0.5. So similarly, so this is like saying f of x equals 0.5. Then it means x is f inverse of 0.5. Does it make sense? Okay, that's what we're saying. So there's a reason I like to state this, because that will determine the interpretation on the last step. I always put it in every question, so I assume I expect everybody to know that by now. Okay? Okay, so now, having said that, from here, we can cross multiply 5x minus 1, y, x minus 5. 5x minus 1, xy minus 5y. So we are here to make x the subject, 5x minus 5y, no, 5x minus xy. X is being made the subject. Negative 5x plus 1. So this is x, 5 minus y, 1 minus 5x, if I rearrange properly. So x, yes?
1 minus 5y. Like,
What's that?
1 minus 5y, you wrote 5x.
Oh, sorry. Maybe I didn't get enough sleep. That's what Callista is about to say. So this is y, this is y. Thank you. So this is y. We're going to wrap up soon because it's time. So if this, and this can be written in another way. Do you agree? It could be 5y minus 1 divided by y minus 5. Does everybody know how this became this? Talk to me, everybody.
Yeah.
So if both of them are subtraction, you can just change their position. We are not just changing their position. This is what is happening. So if you have a minus b divided by d minus e, if you bring out minus from here, you're allowed to write b minus a. If you also subtract minus from here, you're allowed to write e minus d. Because if you open the bracket, this is negative b plus a, which is what you used to have. If you open this bracket, this is negative a plus d, which is what you used to have. So if this minus and this minus cross out, then we are left with b minus a divided by e minus d. So if you have something of this form, you can always write it of this form. So it looks like they both change position. Okay? And that's what has happened here. The reason I'm mentioning that is because I want it to look exactly like the function. Now, we already said from here that when you get x, your x is actually f inverse of y. We mentioned that earlier. I'll keep this in the corner. So this is inverse y, yeah? So let's keep this in the corner just in case anybody needs it. So if this happens, it means that our f inverse y is 1 minus 5y divided by 5 minus y, which means we can change the variable f inverse x to be 1 minus 5x divided by 5 minus x, which doesn't look like the original function, which is why I said we could write it in the other way. F inverse of y is, if we use this, because they are the same, yeah? So it will be 5y minus 1 divided by y minus 5, or f inverse of x, if you change the variable, 5x minus 1 divided by x minus 5. So it's possible you try to find it and you get this. Don't forget you can simplify to put it in this form. So it looks exactly like the original function. I mean this. Okay, so using algebra, this is how you can show that it's self-inverse. So you may just write your conclusion. Since, so my conclusion will be, since f of x is the same as my f inverse of x, then f is a self-inverse function. So that's the explanation. That's the explanation. That's the explanation. Any questions, please? There is something I wanted to do today, but we do not have the time. I'm referring to question 3. So can I ask us to make an attempt? I prepared some kind of, I'll release it very soon, sorry. I prepared some kind of investigation because I thought we'll quickly rush through this, but I realized there are so many things we need to learn together rather than rushing through and lacking basic understanding. And I do not want to show whereby only a few people are, getting what we're saying and some people are struggling with it. So it's okay that we actually focus on this. So next time also we'll dedicate our time on this worksheet and hopefully that will be the last. All right. So please bear with me. The investigation will not, because I already scheduled the post for the investigation to be on the online tomorrow. So I'll change the schedule post to maybe Thursday. So after Wednesday's class, then you can see it on Thursday, or maybe after Wednesday class is automatically on your wall, and you can take your time and do it before Friday. All right, the investigation is meant to be done ahead of the next thing we want to do. But I don't think we want to go to that yet. So I'll change it. It might even be next week, depending on how far we have to go deeper into functions. We still have some things we haven't said about functions, one-on-one function, odd and even functions, and things like that. Any questions, please, for today? No questions?
No.
No questions.
No? Okay, so please do not forget, a function is self-inverse if it is the same as the original function, okay? On the graph, it is symmetric about the identity, the graph of the identity function, which is y equals x. It is symmetrical about that. So meaning, if it is symmetrical, this and this looks exactly alike, even though everything is still the function, okay? That's how you can see that. And one of the other things we mentioned is what? How do you know if you have coordinates, just xy coordinates, it's going to be a function if whenever you compare two of them, any two means you have to consider all the possibilities. If you consider any two, the x coordinate is the same means it's not a function. Okay, and if you are referring to the inverse now, it means if you consider the coordinates, consider the y, there will be certain y that are the same for two different coordinates. Then there's a problem. You're not supposed to have that. Okay, the inverse will not exist if you can pick if you can see y coordinates without actually finding the inverse that are the same. So always refer to the y coordinate by inspection when trying to discredit a relation from being an inverse function. And always refer to the x coordinates to be able to say it is not a function. If the two x coordinates are the same, if for two pairs of coordinates, the x coordinates are the same, then it's not a function. And the reverse is the case of inverse. And that is actually the summary of all the things we have mentioned today. So questions that relate to this, can you please try them? We talked about those two self-inverse functions just now. What is that? Question 2. So please make an attempt on 2B on your own, inspect the graph, write your comments, and use algebra as well. The one in question 1 that we have not mentioned, please do the same. And before we come tomorrow, I need everyone to try, no, on Wednesday, sorry. I need everyone to make an attempt on 3 and 4. Make an attempt on 3 and 4. Then when we come to class, we'll see if it is right or wrong. Okay? How about this? Everybody take note of these numbers. Attempts. It doesn't have to be right. Take note of these numbers. Question 1, question 3, question 4, question 3, question 4. Question 8. And question 11. No, question 8, question 11, and question 12. Make attempts. Okay, it doesn't have to be right. Make attempts. Again, question 3, question 4, question 8, question 8, question 11, and question 12. Make attempts. All right, so maybe I write it on the board also. Question 3, question 4. Give me the rest. Anyone?
Question 8, question 11, and 12.
Okay. So attempt this. Okay. If there are no other questions, just for our board records, I'm just going to put today's date here. So if I'm looking for a document, I know where it is. So today is Monday, 23rd. Okay, any questions? If there are none, I'll see you guys on Wednesday. Sorry we had to extend our time. You know, I love the 2-hour stuff, but of course, due to the current situation in school, the 2 hours will have been enough so everybody can get different questions and things like that. But let's just manage the situation for now, okay? All right, see you guys on Wednesday. Stay safe, wash your hands, stay healthy.
Bye.
Good enough sleep.
Bye.
Bye. What is Clarissa still doing here? Go!